And so let's suppose we have an empirical formula of CH2O and has a molecular mass of 180.16. First step is going to be, as we did before, is let's find what the empirical mass is. We have one carbon, so we say 1 times the mass of carbon, 12.01. And then we're going to add the number of hydrogens. There are 2 hydrogens, so 2 times the mass of hydrogen, 1.01. And then plus, that's a 1, not an 11, plus we have 1 oxygen times the mass of oxygen, which is 16.00. And so if we go ahead and get our calculators out on that, we say 1 times 12.01 plus 2 times 1.01 plus 1 times 16. We do that, we get 30.03. And so 30.03 is our empirical mass. So then what we want to do is we want to go and take that molecular mass, which is 180.16, divide it by that empirical mass, 30.03, and we go ahead and do that. And if you run those numbers here, we get something that is just slightly under 5. And so 5 is our scaling factor. And so it's late here. 6 is what we get. 180 divided by 30 is 6, not 5. I really do need to use a calculator, not do it in my head. So I get 6 for this one. And so as a result, that my molecular formula, since my empirical formula is CH2O, my molecular one is going to be C6H12, because 2 times 6 is 12, O6. And so that is going to be my final empirical formula, my final molecular formula. Note that we didn't really look for which one was the cation here. It's sort of difficult to tell on this one. Carbon can be a cation, hydrogen can be a cation, oxygen can't. This particular type of formula, one that has carbon, hydrogen, and oxygen in it, is actually called an organic molecule. Organic means it contains carbon. And usually has chains of carbon. There's lots of carbons. Here we have 6 carbons in this one molecule. We're really not going to discuss these in too much depth in this class. We don't really cover too much organic chemistry, but just sort of be aware that organic molecules like this typically use a different system, both of naming and of writing them out that other ones are. And so if you get one that's carbon, hydrogen, and oxygen, and there are lots of carbons in it, it really is okay if you just write it out. Just put the carbon first. Is usually what you do. It's usually a carbon first type atom. The rest of them you can sort of fill in there. I'm not gonna sort of hold you to finding the cations on these because it's really difficult to find a cation in organic molecules like this. And so don't worry about it if you have one like this that it's not clear what the cation is. Just go ahead and write it out, and you'll be fine with that. Let's take a look at our next one here. Empirical formula is H2SO4. The molecular mass is 98.08. And so first step here is, once again, let's find what the empirical mass is. I have 2 hydrogens, so 2 times 1.01, and then plus I have 1 sulfur. And so I say 1 times, you look at the periodic table, the mass of sulfur is 32.07. So I have 32.07, and then plus I have 4 oxygens, so 4 times 16.00. And so if we do this time I will use a calculator. What we find is that 2 times 1.01 plus 1 times 32.07 plus 4 times 16. And when you do that, you get a total of 98.09. So that's what we get for our empirical mass. So once we've got that empirical mass, the next step is going to be to take that molecular mass, which is 98.08, and divide it by the empirical mass, 98.09. And what you notice here is that this is basically 1. This is one of these cases where the empirical formula and the molecular formula are basically the same thing, and or are the same thing. Is that the molecular formula is its empirical formula? So our answer is just this H2SO4 right there. That is our final answer on that one. It is both the empirical and the molecular formula. And if you ever find that your molecular mass is the same as your empirical mass, it means they're just the same formula, and so it saves you some work there.